Okay, welcome once more. So far I've received the name of a class rep and the vice class rep, and the class rep is Mary. The vice class rep is Blessing. So for Blessing, may you please, if you hear me, send me your details, your email address and your cell number so that we can be able to communicate. Thank you. So now, without any waste of time, let's just go to the module. We have to start with the introduction, like I've indicated before, that we are going to start with the introduction so that we can remind you for something that you know about the sampling without going far to the details, without going to the more complicated or more advanced topics. It's very important to start with the simplest one, or those that we know most. Then we advance on that. So let me just try to go to the window journal so that we can start with our lecture. Okay, just wait a bit. Okay. Wait a bit while I'm still busy. Okay, just wait for me. Something is not working here. Something is not working here. Sorry for that. I don't know. Okay. Okay. Can you see something?
No, sir.
Can you see?
No, yeah.
Yes,
The board?
yes, yes,
Okay.
nice.
Okay.
Yeah.
That's fine.
I can see.
Okay. Now let's start with our lecture. That's lecture number 2. Okay. 2. So it's about introduction. Says the introduction on sampling theory. So anyway, we have to start by defining what is a sampling. Is there anyone who can give me the definition? Start defining the sampling. Anyone can give me the definition? Okay. Sampling is a process. That's a process of selecting the number of subjects or objects, number of subjects or objects from the population. from the population to be studied. Okay. So sampling is a process of selecting the number of subjects or objects from the population. So now, it is an ideal to select the entire population, but it is advisable to use a sample very often. Are we together? It's an ideal to select the entire population, but it is advisable to use the sample very often. Now, the question is, what is the population? So how do you define the population? Anyone? I think you know these things. What is the population? Okay, the population is the entire collection of things, collection of objects, collection of subjects you are interested in. In other words, is the entire collection of you can say people or things or subject or object you are interested in. The entire collection of objects, people, things, or subjects that you are interested in. Okay. So now, what is the definition of a sample? What is the definition of a sample? It's a subset of a population, isn't it? A sample is a subset of a population. Okay. So that means we have the entire collection of people, then from there you get a sample. In other words, a sample you get it from the population. So how can you illustrate this using the example? Let's use the example to illustrate this. For example, so you can give me any example, but let me just give you one. It's all registered students at University of Limpopo can be regarded as a population. All registered students at University of Limpopo, okay, can be regarded as what? As the population. So this is our population. We're considering this as our population. Okay. Like I said, you can get the sample out of that population. So what is the sample? If all students at University of Limpopo are regarded as a population, what is the sample out of? You can give me the sample. You can say SSTC 032 students at the same university, okay, can be regarded as what? As the sample. Okay, this is the sample. Okay, we have all students or all registered students at the University of Limpopo. We regard them as what? As our population. And from that population, we can take a sample, which is what? Sampling theory students. So can be our sample. Our mathematics students can be our sample. Our health students can be our sample. There are many examples that you can give there. Okay. So now, let's proceed. What is a sampling unit? You have defined what a population is. You have defined what a sample is. So what is a sampling unit? Sampling unit. So sampling units are non-overlapping collection of elements subject, object, whatever, from the population that covers the entire population. That is the what? The sampling units. So sampling units are non-overlapping collection of elements from the population that covers the entire population. Okay, from the example that we gave above, which is all registered students at the University of Limpopo, that we regarded them as what? As the population. We can get a sampling unit out of that example. Who can tell me, what is the sampling unit out of that example? All registered students at University of Limpopo. Can you take the sampling unit out of there? We are saying a sampling unit. You need to know that is what?
Student.
Come again? Yes, student. Okay. So that means our sampling unit there is a what? It's a student. Okay. It's a student. That is our sampling unit. So this is how we define sampling, population, sample, and sampling unit. Okay. Now, why do we sample? Okay. That is the question that you have to ask yourself. Why do we sample? Or what are the reasons for sampling? So let's go to the reasons for sampling. Can I go to the next page, please? You're still ready?
Just 1 minute.
Yes,
Okay. So we just want to find out what are the reasons for sampling. We're not just doing sampling. There is a reason behind that. So what are those reasons? We just want to find out. Reasons for sampling. There are many reasons for sampling. A lot of them. Okay. There are a lot of reasons. I think you're done. You have to be fast when you are writing, isn't it? We don't have enough time. Today is only one period. So we have to cover as much topic as possible. Can I proceed?
Yes, sir.
Okay, thank you very much. Let's go to the next page. Now, what are the reasons for sampling? Why do we sample? Okay, just say reasons for sampling. Is it important to sample? Okay, if it's important, tell us the reasons. Number one.
So let's move.
Come again. Reasons for sampling. Number one.
It takes less time to work with a sample
Yes,
compared to working with a population.
definitely. We just want to minimize time. Just want to minimize time. Another one?
Cost less.
Yes, minimize cost. Number three. Minimize difficulties. Okay. You say minimize difficulties. Number four. Just want to be accurate. Just want to be accurate. So those are some of the reasons for sampling. Just want to minimize the time, we minimize the cost, minimize the difficulties that you can encounter. Just want to be accurate. So now tell me, what are the types of sampling that you know? What are the types of sampling?
Sir,
Yes.
it's probability sampling and non-probability sampling.
Okay.
I also
Types
have a
of sampling.
question here. Sir,
Eh?
I also have a question here.
Yeah.
I think what you just mentioned now, can you give us the reason for sampling? Because what you just mentioned now is the advantage. Those are the advantages of sampling.
Those, they can be reasons, because the main idea for sampling, we just want to minimize time. We just want to just minimize cost, because if you just take the whole population, it will take you time to finalize your research. Are you together? And it will cost you a lot, because now the population is big. You're taking the whole thing. So it's going to cost you so much than using the sample. Are we together? So those are the reasons. That is why I'm saying those are the some of the reasons of sampling. You might have a lot of reasons that we didn't mention here. So we are not saying this is the only reasons for sampling. We are saying this is some of the reasons for sampling. And then remember, we are comparing the sampling and the population. That is why I say it's an ideal to use the entire population, but it's advisable to use the sample. So that is why in this case we are considering the sample, because it minimizes time rather than using the whole population, where it's going to take us, instead of taking you 2 days, it take you maybe the whole year doing your survey. So maybe of using maybe 100,000, use 1 million for collecting data. So those are the some of the reasons of sampling. I'm not saying that this is the only one. There are many of them. So if you take them as an advantage, at the other hand, can also be a reason. Are we together?
So can we please proceed, because some of us will be facing load shedding not so long. So can we please proceed?
Okay. Okay, it's fine. It's fine. So now, what are the types of sampling or sampling procedure? There are 2 types of sampling. Number one is what?
Sampling, random sampling.
Yes. Yes. You can say random sampling or probability sampling is the one thing. That is number one. Probability, or sometimes you call it random sampling. Okay. The second one is what? Obvious, the opposite of that one is non-probability or non-random sampling. Non-probability sampling. Okay. The question is, what is a probability sampling or what is a random sampling? Who can define it for us? Here in the probability sampling or random sampling, elements are randomly selected or randomly being selected from the population. Here elements are randomly selected, being selected from the population. Okay. So in other words, each and every element has equal chance of being selected from the population. That is what it means. Okay. So what about the non-probability sampling? Like I said, it's the opposite of that one. So in that case, here elements are not randomly selected from the population. Okay. For the first one, elements are randomly being selected from the population. Second one, elements are not randomly being selected from the population. This is the opposite of that one. Okay, are we together? So now, what are the types of probability sampling now? Okay, you define a probability sampling. So now we just want to see the types of probability sampling. What are they?
We have simple random sampling, stratified
Yeah.
sampling, cluster sampling.
Okay, let's put them here. Types of probability sampling. Okay. Number one, it's a simple random sampling. Simple random sampling. It's SRS in short. It's a simple random sampling. Number two, systematic random sampling. Number three, stratified random sampling. Number four you said is what? Cluster.
Cluster.
Call it cluster. Yes, cluster random sampling. Now, those are the probability sampling, types of probability sampling. Okay, so in this module for SSTC 032, which we call sampling theory, we are going to discuss in details the simple random sampling as a chapter. Okay, then we go to the systematic random sampling as a chapter, and then stratified random sampling as a chapter, and then the last chapter will be a cluster random sampling. We're going to discuss this one in detail. Are we together? So now let's go to the non-probability random sampling. Can I go to the next page, please?
Yes.
Okay, types of
sir.
non-probability sampling. Okay, let's go there. Got stuck. Okay, let and go this way. Okay, now types of non-probability sampling. Of non-probability. Simply. So we have 4 of them as well. Number 1, do you know them? Number 1 is convenient. Convenient. This one is E, remember. Convenient sampling. Okay, that's number 1. Number 2, we call it quarter. Quarter sampling. Number 3, judgmental. Sampling. Number 4, snowball sampling. So here we are just mentioning the types of non-random sampling. We won't go in detail on how to just explain in detail on how convenient sampling are calculated and all those stuff. So we just mention them as they are. Okay. So now the question is, from probability sampling, I mentioned simple random sampling. So the question is, what is a simple random sampling from probability sampling? What is a simple random sampling? SRS. What is that? So simple random sampling here, SRS, here every element of size n has equal chance. Has equal chance of being selected from what? From the population. Okay. So in simple random sampling, every element of size n has equal chance of being selected from the population. So that size n represent what? This small letter n is a sample size, isn't it? Yes, it's a sample size. So you have to know them, because we are going to work very often on that sample. So you have to know it. What does it represent? Okay, now let's go to the systematic random sampling. What is systematic random sampling? So systematic random sampling, what is that? So systematic random sampling, here the units are selected at a specific what? Interval. Okay. Units are selected at a specific interval starting from a random starting point. So you can go to the next page, isn't it? In systematic random sampling, the units are selected, or the elements are selected at a specific interval starting from a random starting point. Okay. See now. You're done.
Yes.
Can I go? Okay, thanks. Interval. Interval starting from a random starting point. So we can illustrate this using example. Okay, let's go to the example on how to find the what to call the systematic random sampling, so that you can understand it better. For example, let's go to the example. Okay, suppose a sample size of n. Write it down. Suppose a sample size of n equal to 20. Okay. Has been selected. Let's say from the population of size n equal to 200. Okay. So now we want to use systematic random sampling to draw a sample of size n equal to 5. Let's say we want to use, we can say use systematic random sampling to draw a sample of size n equal to 5. Okay, where do we start? If you still recall, where do we start? We have been
Sir.
given this.
Sir,
Yes.
we start by dividing 200 by 20. Then
Okay,
we're going to get 10. Then we're going to count the first 10 members. Then we select the number 10. Then we count the next 10 members. So select the number 10 starting from where we stopped until we
How
reach
did you...
the 200.
Okay. No,
Yeah.
I get you. Okay, let me just go step by step so that for those who don't understand what you're talking about, so that they can understand it better. Okay, there are two things that you have to do. Number one, you want to use systematic random sampling. Number one, you are supposed to have a starting point. That's number one, have a starting point. Because according to the definition, if you still recall, it says you select, the units are selected at a specific interval, starting from a random starting point. So you're supposed to have what? A starting point. A starting point. That's number one. Number two, you are supposed to have what? If you check the definition there, it says units are selected at a specific interval. So that means you are supposed to have what? An interval. That's number two. Okay. Let's go back to number one. Point number one, which is a starting point. So a starting point, where do you start? Who can tell me, where do you start? Where do we start? Simanga, you are the one who was explaining this. Where do we start?
We start at 10. We start
Okay.
at
Why
the
10?
number 10.
Why 10?
Oh, okay. We to find where we start, to find the random starting, we're going to take the total number of the population divided by the sample. I said 200 divided by 20. Then we'll start at 10.
Okay, understand what you're
Yeah.
saying. Okay, thank you very much. So now, Because the point number 1 says starting point, the question is, where do we start? So if you check here from the definition again, it says units are selected at a specific interval, starting from a random starting point. Random starting point is anywhere. You can start at any number. You get that? You can start at 2, you can start at 3, you can start at 10, anywhere. So in this case, let's start at 2. That is our random starting point. It's 2. Okay? You can start at 10, you can start at 5, but in our case, to be uniform, let's start at 2. Okay. Now, how do you find the interval? Interval, if you still recall, is represented by k, isn't it? And k is equal to n over n. What is the big N represent? Big N represent the population size, and small n represent the sample size. So from the given information, what is our population size? It's 200, isn't it? Then you divide by the sample size, which is 20.
Sir,
And the answer is what? The answer is 10,
10.
yeah?
sir,
10. This is what Simanga was indicating before, that he take what, you divide by what, and
Sir.
get 10. Okay. Yes.
sir.
Yes,
Since in reality it will be impossible, if not cumbersome, to calculate the sample size of the population, how do we go about finding the interval if we don't have the population number of the population element that constitutes for the population?
In this case, to draw the sample using systematic, they have to give you the population. They have to give you the sample. Otherwise,
But I can continue with you guys. I know those things. If you don't mind.
Relax, Awena.
Honey, where is guys?
Wabishusha barenta balekre rekreza.
Guys, I think it's almost time out. So I will check it. I will give you feedback. Gori. What's it?
Hey, the class is over, Fit. Say.
Set doesn't have data now.
Say doesn't have It's 9. The class is over. Let's prepare for score.
Yeah, mi famba kahle hinkwenu, fambani kahle.
Oh, are you from Botswana or what? You would have been run back. Eh?
Increase the volume, man. That song is nice. Increase the volume.
Yimukhethe. What the
Ish, guys, there's only 7 of us left or 5. Like, what are we waiting for? It's like we're in denial.
When I emailing you,